Okay, I'm going to give you an analogy that I hope kind of works for somebody on how to think about physics problems and physics word problems. So the analogy equation that I have is dogs divided by cats equals fur ball. And the word problem I have is you have 2 beagles and 4 Siamese. What is the fur ball? In this problem, we don't have the word cat or dog listed here. Instead, we have beagles and Siamese, both of which are breeds of dogs and cats. And then we do have the word fur ball, so we know that ties directly into the equation that I gave you of dogs divided by cats equals fur ball. So for this problem, 2 beagles, that's a breed of dog, we can put that in for dogs into this equation, and we can see beagles as a unit of dogs. 4 Siamese is a breed of cat, so we can plug that into where it says cats, and we can see that 4 Siamese is a unit of cats. Okay? So then, what that would look like for an equation is, this is plugged into the equation. 2 beagles, beagles again is our unit of dog, and 4 Siamese, again our Siamese, is a unit of cat, and that would equal fur ball. And 2 divided by 4 gives us half, so then that would equal half. And then our fur ball units maybe are in beagles over Siamese in this case, which does happen in some physics problems where your units are basically what are the 2 units that you just used up in the word problem. So then let's look at an actual physics problem here. Similar format. We have speed equals distance divided by time. In this particular problem, I do have the key clue words of distance, or at least have the clue word of distance. 2 cars are racing over a distance of 500 meters. Car 1 finishes in 90 seconds and car 2 finishes in 110 seconds. Now here, we need to realize that seconds are a unit of time, and so when we go back to the formula, we already have our distance clearly labeled and stated in the problem, but seconds would be a unit that goes into this part here. And then for the question, it would be what is the difference in time, or what is the difference in speed between the 2 cars? And so then what we would do to solve this is we would plug this part in for distance, and then we would plug these 2 in for time, but we'd have to do this in 2 steps. We'd have to do one equation where 500 is our distance and 90 seconds is our time, and then we have to do a second equation where, again, 500 is our distance and 110 seconds is our time. So written out, what I just said looks like, pause the video so I can write this down. So written out, it would look like this. 500 divided by 90, 500 divided by 110 would give you the speed of cars 1 and car 2. So that is an analogy of how to think about these physics problems and understanding that it is important to know the units and what part of the equation they belong to, knowing the units of time, knowing the units of distance, and also their abbreviations. Those are going to be really important so that you know where to plug things into an equation. So I hope that provided some clarity of how to think about physics equations. 2 keys that I have found that help with solving physics word problems and what goes where is color coding the variables in the word problem and the equation itself, which is why I had blue and red on one of mine. The other thing that does help sometimes is listing out your variables of what you have, such as what I have from an earlier example of a problem of where I have speed, distance, and time. I can clearly see what I am missing here for this problem. So I hope that helps. If not, then you might need to go back and revisit some math concepts.